Alright, so graphing logarithms is a bit more difficult than graphing most other functions because we're just not used to using them. We don't have a full grasp of what they really mean, and I really don't like graphing logarithms. I prefer to graph their inverses, that is an exponential function, and then reflect those across the line y equals x to get the graph of my log. So, to graph this log, what I'm going to do, is I'm going to find its inverse. So I change x and y. And now I solve for y. So I'm going to subtract 2. And now, central to logarithms, when we're solving a logarithm for a variable that's stuck inside of the logarithm, we need to change to exponential form. So we get the log by itself, which I have, and now I change to exponential form. What's the base of this logarithm? The base is 2. What's the exponent? The exponent is what logs are equal to. And this equals y plus 1. So y is equal to 2 to the x minus 2 minus 1. So now we graph this, and to do that, we identify the shifting that might be happening. So the minus 2, that means shift to the right 2, and the minus 1 means go down 1. I'm going to start with the graph of y equals 2 to the x, the parent function. And this graph goes through the point 0, 1, because 2 to the 0 is 1, and 2 to the first is 2. And I'm going to take these points along with the horizontal asymptote and move them to the right 2 units and down 1. So this y-intercept goes right 2 and down 1. This point here goes to the right 2 and down 1. And the asymptote going left and right doesn't matter, but it does go down 1 unit. So the graph of my exponential function looks something like that, with an asymptote at y equals negative 1. But remember, that's not what we want to graph. We want to graph this logarithm that I have up here at the top. This orange function down here, that is the inverse of this logarithm. And the way we deal with graphs of inverses is we interchange the x's and the y's. So this point over here that is 2, 0 becomes 0, 2. That's this one. This point that's 3, 1 becomes 1, 3. And the asymptote that was at negative 1 at y equals negative 1 goes to x equals negative 1. It's a vertical asymptote. And we get that green graph that has a domain of x has to be greater than negative 1 and a range of all real numbers. And this is what we should expect if we think about the transformations of the logarithm of any function. This plus 1 means we're going to the left 1. The asymptote is left 1 from the y-axis, and then left 1 up 2. If you look at the graph of a basic logarithm, it passes through 0, 1. So moving left 1 and up 2, we get that point there. But I never, ever, ever try to graph a logarithm. I always graph the exponential function that is its inverse and reflect the points.